Hi, this is Mark Roth, and this is Mathematics for Social Justice. This is going to be a lesson called Bowling Pin Puzzles Part 2. This lesson I developed with a partner named Jessica Delgado, who's a mathematician and a math teacher. And if you noticed, I don't have a rectangle at the top. So we're going to not use a number. We're going to use numbers from this set. But we're not going to use one of them, okay? So I'm going to pick a card randomly. So I just picked up a card, and it happens to be 7. We're going to use all of the numbers 0 through 9, but we're going to omit one of these numbers. First of all, let's write no 7. And we're going to add in a kind of a funny way. I'll show you as an example. So this will be 5, and this will be 3. This will be 1, and this will be 9. So here's how we add. 9 plus 3 is 12. I'm going to put down the 2 and kind of throw away the 1. And 3 plus 5 is 8. And 5 plus 1 is 6. And 8 and 6 is 14. I put down the 4 and forget all about the 1. And then 2 and 8 is 10. I put down the 0 and forget about the 1. So now we've used all of the digits except for 7. 7 was one of these 8 numbers that I was going to pick one and not use it. But I'm going to use all the digits 0 through 9 in this pyramid except for 7. So in other words, I wasn't allowed to omit 0 or 5, but I have to use 0 or 5 in this pyramid of numbers. I've used 0, 1, 2, 3, 4, 5, 6, no 7, 8, and 9. And all the addition is correct. Now, if you remember, if you saw the previous video, we're actually adding on a clock. And the clock I call mod 10. It's got 10 numbers on it, not 12. So for example, when you're adding 9 and 3 on this clock, you would start at 9 and go 1, 2, 3, and then you'd land on 2. But that's the same as saying 9 plus 3 is 12, and write down the 2 and forget about the 1. Now, the question is, how did I know how to find these bottom numbers so I'd use each number? Well, actually, it's kind of a parlor trick. And the rest of the lesson, we're going to show you how to calculate that these are the numbers that work. To start with, we're going to keep 0 there, because 0 any place except for one of the 2 top spaces would cause repeats, and we don't want any repeats. And we're going to use an algebraic solution. So let's go ahead and put C here, B here, and A here. And these are variables. They stand for the numbers, 0 through 9. But of course, we're not using 7. So now to continue with the algebra, B plus something adds up to C. Negative B plus C. So the B and the negative B will cancel, and the C will survive. And then here, I'm going to cancel the negative B and the C. So I cancel negative B with positive B, and I cancel C with negative C. And then here, I need to cancel the A and have B survive. So that's going to be negative A plus B. And here, I want to cancel the negative A, so I'll need an A. And I want to go from positive B to negative B, so I'm going to need negative 2B. And then I want a C. And then here, I want to cancel A. And I want to go from negative 2B up to B, so that'll be 3B. And then I want to go from C to negative C, that'll be minus 2C. So now, what's going to happen if I add all this together? Well, if I add all this together, I'm going to get all these numbers: 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6. Now, I'm not going to have a 7, but I'll have an 8 and a 9. Well, all the numbers 0 through 9 up to 45. So if I don't have a 7, they're going to add up to 38. So this will be 38. But on this clock, 38 is just 8. But on the clock, it's equal to 18, 28, and so on. If I add all this together, it's going to add up to, say, 18, for example. So let me do some adding. Now, the nice thing about adding is I get to cancel. So I cancel the C and the negative C, the B and the negative B, the A and the negative A, the A and the negative A. I can cancel 2 C's with a negative 2C. I can cancel 2 B's with a negative 2B. And all I have left is 3B. So 3B is equal to 8 or 18, but I'll use 18 and divide both sides by 3. And that cancels. So I get 6. So this B is 6. So I can replace this now with 6. So now I know 2 of the numbers. I know where 0 is, I know where 6 is. So at this point, I can try to finish the problem. Now, it still seems kind of hard. Maybe there's one more thing I can do to help. And so I'm going to change clocks. I'm going to look at a clock called Mod 2. This clock has only 2 numbers on it. If I add 0 and 0, I get 0. Start here at 0 and go 0 spaces, so you stay right there. Suppose you want to add 0 and 1. You start at 0 and you add 1 space, you land on 1. And what about 1 plus 1? You start at 1 and you go 1 space, and you land on 0. This is the exact same behavior you get from even and odd, because if you wrapped around, 0, 1, 2 would be where 0 is, 3 would be where 1 is. If you keep wrapping around, all the even numbers are the same place as 0. All the odd numbers are the same place as 1. So you can think of 0 as representing all the even numbers and 1 as representing all the odd numbers. We're just saying even plus even is even plus odd is odd, and odd plus odd is even. Now, if I don't use 7, I'll be eliminating one of the odd numbers. I want only 4 odd numbers. So let's start at the top with 0 and 0. And let me just try another 0 here. And then I can put 4 odds right here. So this is a possible template where I'm using zeros again instead of any even number and ones. So it's going to be 5 evens and 4 odds. So now, is there another way to do it? Well, let's try 0 and 1. Let's see if we can end up with 4 odds. So if I do this, I can go 0, 0, 1, and maybe 0, 0, 0, 1. That's only 3 odds. That doesn't work. Let me try 1, 1, 1, 0. That's too many odds. I got 5 odds. So let me try changing the second row from 0, 0 to 1, 1, and try a 0 there. Then I can try maybe a 0 here too. 0, 0, 1, 0. That works. So this is another possibility where I get 4 odds. So let me try these 2 possibilities and see if I can get a solution. Now, first of all, this has to be even. So this is a 0, and this is a 0. So both of these possibilities are still good. So I can try, I'll go in order, I'll try 2 here. So if I put 2 here, this would be 8. And this would also be 8. So that's not a solution because I can't use 8 twice. So let me try using 4 here then. Well, 4 would cause another 0, so 4 is no good. So let me try, I can't use another 6. I can't use another 0. So let me try using, I I've tried 2, I've tried 4. I can't use 6, so I think that leaves only 8. So 8 and 16 is 4. This would have to be 2. So we'll see if this gives us a solution. Now these are all going to be odds. So let me go in order again. If I go 1 and 1, I'm using 1 twice. That's no good. So let me try a 3 here. If I try 3 here, that's 9. And that's a second 9, which I can't do. So 3 doesn't work. Let me try 5. That would be 5 and 7 and 1 and another 5. So 2 5s is no good. So let me try 7. That would be 7 and 5 and 3 and 3. I have 2 3s, so that's no good. So my last hope is to use 9. So I put 9 there. This will be 3. This will be 5. And this will be 1. And let's see if that's a solution. So I've got 0, 1, 2, 3, 4, 5, 6, no 7, 8, and 9. So we found a solution. Now let's write that down. So we have a bottom row of 9, 3, 5, 1. Let's try this other template and see if we get a solution. So we know this is 6. Let's try different odd numbers here. So let's try 1. That would make this 5 and make this also 5. So 1 doesn't work. Let's try 3. This is 3, this is 7, and this is also 3. So 3 doesn't work. Let's try 5. If this is 5, 9 and 6 is 15, so that would be 9 and that would be 1. Let's start with an odd number. We've already used up 5 and 9, so we could try 1. We've already used 1 too. So we could try using 3 in the spot. And then we get 6, and then we get 0. So we get another 0. So we tried 1, 3, 5, and we can't put 1, 3, 5, and 9 in that spot. And we can't use a 7. So basically, we've tried every example. So it turns out the only solution is 9, 3, 5, 1. And we get 6, 8, 12, 14. And again, we have 0, 1, 2, 3, 4, 5, 6, no 7, 8, and 9. And this is the only solution. What we want to do, though, is get a general solution. So remember when I did the trick, I didn't know that I was going to pick a card that would tell me not to use 7, but I was still able to come up with a bottom number. So what I would like to do is basically have an algebraic solution. So now we're going to calculate the general case where instead of saying no 7, we're going to say no D, where D is a member of this set. So we're still going to have 0 here. And we're going to have C, B, and A here as before. And so this calculation will be familiar to us pretty much. So we have negative B plus C, and we have B minus C. We have negative A plus B, and it's going to be A. We're going from B to negative B again. That's negative 2B. And we're going to add the C. And then here we're going to have cancel the A. Go from negative 2B to B. That's plus 3B. And go from C to negative C minus 2C. So this is a repeat of what we did before, but just doing it again. Cancel the B and the negative B. Cancel the C and the negative C. Cancel A and negative A. Cancel A and negative A. And we're going to cancel these two B's with negative 2B. And we're going to cancel these two C's with negative 2C. So now to do the calculation, we have 3B It's equal to 45 minus d. So all the numbers 0 through 9, where you don't use a d, they're going to add up to 45 minus d. So now we can go ahead and change 45 if we want to, let's say 15. And we can change the minus d to 9d. Plus 9d. Now why is negative d equal to plus 9d? Because on the clock, if you go backwards, this becomes negative 1. So negative 1 equals positive 9 on this clock. That's why I can change negative 1d to positive 9d. Now if I go ahead and divide by 3, I end up with b equals 3d plus 5. And this is our result. So we just know now that this is going to be 3d plus 5. So we can erase all this. And write 3d plus 5. Now we're going to take a little guess. In our first calculation, 5 turned out to be here. And when you multiply by 3, 7, or 9, 5 will still be there. So in 4 of the 8 cases, we know 5 will go there. Let's just assume maybe we'll get lucky and it'll be there in all 8 cases. So if this is 5, this is 3d. We're talking before about this kind of math. We talked about partner pairs. So 1 and 9 were partners because they both make 0. And 2 and 8 are partners. And 3 and 7 are partners. And 4 and 6 are partners. Now, 5 is its own partner. And 0 is its own partner. So in this case, we're trying to make 0, which is the additive identity for adding on this mod 10 clock. And these are the 4 that I call partner pairs. Okay, so these 2, for example, will add up to 0. So these 2 have to be a partner pair. Now, there's going to be a negative d somewhere because all these numbers here are part of a partner pair. So 1 would be paired with 9, 2 with 8, 3 with 7, and 4 with 6. So whatever d is, negative d is going to be on here somewhere. And when I did the example and we used no 7, it turns out negative d, which was 3, turned out to be right there. So let's try that again. Let's try putting negative d right there. Negative d has to go somewhere, and it can't go here or here. So let's just try it there, see what happens. So this would be negative d plus 5. And if you add this and this, the 5 and the 5 cancel, and negative d and 3d would be 2d. Which goes with our example. When we used no 7, 4 was there. And 2 times 7 is 14, which equals 4 on the mod 10 clock. Now this would have to be d plus 5. Which makes this 2d plus 5. The question is this the algebraic formula that works in all cases? We're not going to go through every example. Let's see a couple of examples. Let's try putting an even number here, and let's try putting an odd number here. So let's start with just 1. If that's 1, that would be, so in this case, d equals 1. All right? So 2d plus 5 would be 7. And negative d would be negative 1, which would be 9. 5 would always be 5. And 3 times 1 is 3. So let's see if we get a solution. That'll be 16, 6, 14, 8, 12, and 0. So we used everything except what? We didn't use a 1. So like I said, when d was 1, we don't use, that's the number we don't use. So we used everything but a 1. So we tried d equals 1 Let's try d being an even number. Let's try d equals 2. So this would be here negative 2, which would be 8. This would be 2 times 2 plus 2, 5 is 9. I'll put 9 there. And then 5 is always there. And then 3 times 2 is 6. And if you add up, you get 1, 13, 17, 0, and 4. So when d equaled an odd number, this algebra gave us a solution. And when d equaled an even number, we also got a solution. So this algebra works for all 8 cases. And it should give you the unique solution. So all you got to remember then is the bottom row. So you would always put 5 here, and negative d here, and 3d here, and 2d plus 5 here, and then add up. And you're going to do that solution. So this could be a nice lesson for a algebra class or a math circle. Okay, so now just to conclude the lesson, let's try to find all the possible solutions. So let's start with no 1. So we can put 5 here, and then no 1, the opposite of 1 is 9. So when d is 1, this is 5, and this is inverse of 1, okay? The additive inverse of 1. Now this is going to be 3 times 1, so it's 3. And this is going to be 2 times 1 plus 5, so it's 7. So if we add up, we get 6, 4, 8, and 2, and 0. So we should have everything except a 1. So we have a 0, a 2, a 3, a 4, a 5, a 6, a 7, and an 8. Now, to get the other solutions where there's an odd number right here, we can times by these numbers 3, 7, and 9. And these are the numbers that are less than 10, that are relatively prime to 10, except for 1. Now, when you times this by 1, you get the same thing back. But what happens when you times by 3? Well, let's just times by the bottom row. And we're still working mod 10. So 3 times 7 is 21, I just write 1. 3 times 9 is 27, I write 7. 3 times 5 is 15, just write 5. And 3 times 3 is 9. Now, since last time we were doing no 1, when we times by 3, you times this by 3 as well, and we're going to have no 3. So this will be 8, 12, 4, 0, and 6. And that is no 3. We have 0, 1, 2, no 3, 4, 5, 6, 7, 8, and 9. So let's go to no 7. Okay, so now we're going to times by 7. 7 times 7 is 49. 7 times 9 is 63. 7 times 5, we get 5. 7 times 3, we get 1. So this should be no 7. So we get 12, 8, 6, 0, and 14. So this should be no 7. 0, 1, 2, 3, 4, 5, 6, no 7, 8, and 9. So finally we times by 9. 9 times 7, 63. 9 times 9, 81. 9 times 5, 45. And 9 times 3, 27. So then we add up and we get 4, 6, 12, 0, and 8. So we have 4 solutions. Now there's 4 other solutions where this corner number is even. So again, we can do only 1 and times by these 3, 7, and 9 again and get the other solutions. Let's start with no 2. So we'll start with 5. On the left of 5, we'll put negative d, and when d is 2, negative d is 8. And this is going to be 3 times 2, 6. And this will be 2 times 2 plus 5, which is 9. So if we add up, we get let's see if we got no 2. We have 0, 1, no 2, 3, 4, 5, 6, 7, 8, and 9. Now I can go ahead and times the bottom by 3, by 7, or by 9, and I would be getting the other solutions. Now, rather than write them, let's put the solution for no 1 again. So for no 1, this is 5, this is 9. So we want 3 times 1 is 3, 2 times 1 plus 5 is 7, and we get 6, 4, 8, 0, and 2. So let's compare them. So 9's partner is 1. Let's see if 7's partner is in the same place. It's not. 7's partner is here. So if this is for no 2, this is when you have an even number that's not being used, when D is even. And here's when D is odd. The same algebraic formula holds in both cases. But in this case, this left-hand bottom corner, its partner is here. And in this left-hand corner, the partner is here. So that's an interesting thing. The same algebraic formula works in each case, but the structure is slightly different. So the last thing that remains to do is to prove that our answers are unique when we omit an even number. So let's try omitting 2. And let's show that there's only one solution. So we already know the solution when this is 5, and this is 8, and this is 3 times 2 goes here, that's 6, and 2 times 2 plus 5 goes here, that's 9. So we have 7, 3, 1, 4, and 0. So we use 0, 1, no 2, 3, 4, 5, 6, 7, 8, 9. So let me write this over here. And let's try to prove that's the only solution when you omit using 2. So we know when you omit using 2 that this will be 3 times 2 plus 5, which is 11, which is 1 mod 10. So what can we use here now? Well, you could try 3, because there actually is a template where you can put an odd number here that'll work. So let's try putting 3 here. But that means we have to use 2. But we already decided we're not using a 2. So 3 doesn't work there. We've already found a solution putting 4 in this spot. So now let's try putting 5 in the spot. So if this is 5, we already know what this is. Yeah, this is going to always be 1. So we could try 4 here, and 6 here. And then we could try 3 here, 8 here, and then we would need another 6. So 3 doesn't work. We already have 4, 5, and 6 written down. We could try 7, but that would mean we need another 4. So we could try 8 and 3. And that would be 1, but we already used a 1, so it can't be 8. So we could try 9, and that would be 2, but we can't use a 2. So 5 doesn't work. Let's try 6. Again, we know this is 1, so we don't erase the 1. Let's try 6. That could be 5, but that would also be 5. We can't have 2 5s. So let's try 7. That would make that 6 and make that 4. Then we could try, no 2, we could try 3 and 8, but then we would need another 8. So we could try 4, but then we would need 7. Well, we already used 4. So we could try 5, but we already used 6. And we could try 8 and 3, but then we would need another 3. So that doesn't work. And then we could try 9, but we can't use 2. So now we see that we can't use 7. Let's try 8. If we try 8, that's 7, and that's 3. We could try 4, but then we need another 7. We could try 5. Okay, let's try 5 and 6, but then we would need another 1. So we could try 6 and 5, but we're not allowed to use 2. I already have 7 in 8th place. We could try 9, but then we would need a 2, which isn't available. So 8 doesn't work in that spot. Last thing to try is 9. And if that's 9, this is 8, and we would have to use a 2, which isn't available. So we just found out there's only one solution. I'll write it again. So the only solution is when you put 5 here, and then the additive inverse of 2 is 8, and then 5 and 6 makes 1. This happens to be 2 times 2 plus 5, which is 9, which makes that 7, 3, and 4. So this is the only solution.